Okay, friends, so this is part 3 of my factoring review series. So far we've covered the GCF and basic trinomials, and then we talked about grouping and sum of difference of cubes. And so in this video, we're going to kind of refine some of the techniques and look at a few problems that are like harder types of factoring. So first up, we're going to talk about using grouping with trinomials. And there are a couple different ways that you can factor trinomials. I'm only going to cover these two because I think these are kind of the simplest. Let's just jump right into this. So what I want to do is I want to factor 4x squared plus 16x plus 15. Now, before I get too far into this, I do want to just remind you how these videos work. You are going to want to probably pause as we talk about this to write things down and kind of think through things for yourself. Math is not a spectator sport, and the way that these videos are intended to be used are for you to actually pause when appropriate. So as we talk through this, please just remember that. Okay, so I'm going to give you the steps for this. Like I said, pause where appropriate or wherever. So the first thing that we're going to want to do is we want to multiply the first and last numbers together. So the 4 and the 16 multiplied together to make 60, okay? So the next thing that we want to do is we want to find two numbers that multiply to 60 but add to 16. So now I'm taking the answer to 1, and then I'm taking the middle number that we haven't used yet. So 4 and 15 do not add to 16. So even though these multiplied to 60, we need to think of other factors of 60. So if I think through all the different ways I can make 60, what would add to 16? Well, that would be 6 times 10. 6 times 10 is 60, and then 6 plus 10 is 16, okay? So I'll clear a little space. Okay, so the next thing that we want to do is we want to separate the middle term, this 16, using the numbers that we just came up with, so 6 and 10. So this 16x now is going to get broken up as 10x and 6x. And so now look at what we have. We have 4 terms. And so to move forward with this, we want to use grouping to factor. Okay? So at this point, I would say, if you have to write things down and like rewatch the explanation, feel free to do that and pause where appropriate. But what I want to have you do at this point is I actually want you to finish this problem on your own, also just to make sure that you've got it and it's a good review of grouping. So pause here or rewind the video as you need to, and then get caught up and hit play when you're ready. Okay, so I'm going to use grouping. So out of the first 2 terms, I'm going to factor out 2x. Out of the second 2 terms, I'm going to factor out 3. So now this whole thing is set to use grouping. So then this becomes 2x plus 3 times 2x plus 5. And so there's your answer. Okay, so the question I get then is, this seems like too much work. Do I have to use this? So maybe that's what you're thinking right now. So the answer is no, you do not have to use this. This is just another tool in your toolbox. Trial and error is always okay. However, I like to bring up this technique because sometimes people get really frustrated with problems that look like, so if we go back to the original problem, sometimes things that look like this, some people get very frustrated with trial and error and they're like, oh, there's got to be another way. This is another way. Now, I always say that I have the memory of a hamster. And so for me, extra steps, I like have a lot of trouble remembering them. And this to me, like all of these steps that we just talked about, these all feel like just more things that I have to remember. So me personally, I prefer just using trial and error on something like this because at least I know that that will always work, even if it's slightly more frustrating. But some people aren't like that. So you do you. You can use whatever techniques you want. This is just ultimately another tool in your toolbox. So if you really like this, you can try it. But I wouldn't always use this, right? There are a lot of times where trial and error is going to be the better way to go. So use this when needed, I guess is what I'm saying. And if you like it, just make sure that you practice it so that you remember it. Okay, so that was the first thing I wanted to talk about. Let's look at some more tricky examples. Okay, so this first one, I've got negative x squared minus 15x minus 36. Okay, so I think this one is tricky because this starts with a negative x squared, and for whatever reason, that kind of messes with people's brains. So the trick here would be that the negative x squared might confuse the factoring. So what I suggest that you do is factor out the negative 1 first. So here's what that looks like. I factor out the negative 1, and then you see how I've flipped all of the signs here. So now they're all opposite, right? So this is what you're going to want to do. And then from here, you just factor this part right here as usual. So how the rest of this will factor then is, so notice I've still got the negative 1 here, but now I'm going to have x plus 12 and x plus 3. Cool. Okay, so let's take a look at another one. Okay, so for this next one, now I've got 4y cubed minus 28y squared minus 48y. Okay, so this one looks like a trinomial, but the thing that you'll notice about it is that this particular problem has a GCF. So you want to be careful not to be in what I like to call that computer mode where it's like, oh, it's a trinomial, I've got to factor it. And then you see this cubed here and then you're like, oh, wait, what do I do? So you want to be careful with that. And notice, just take a moment to like always pause and always ask yourself first, is there a GCF? Since there is a GCF, I'm going to factor that out. So if I factor out the 4y, what am I left with? Now I'm left with y squared minus 7y plus 12. So this can 100% be factored much more easily than this monstrosity here, right? So always watch out for that GCF because it might make a trinomial that looks super hard. It might actually help make it a lot easier. And so then I can finish factoring this as 4y, y minus 3, y minus 4. Okay, so we've talked about a couple of different techniques at this point. So what I want to do for this next example is I just want to give you a second to try some things on your own. So you try, pause here, think as much time as you need, and then when you're stuck or when you think you've got it or whatever, hit play. Remember, math is not a spectator sport, so this is the best way to get the most out of these videos so that you can learn the most. Okay, so the first thing I'm going to do is I'm going to factor out the negative 1 because it says negative 6x squared. Unfortunately, there's no other GCF. Okay, so now I want to try using that grouping technique. So we can utilize it here. Okay, so the first thing that I'm going to do is I'm going to multiply the 6 and the 3 to get 18. So I've got to think of what two things multiply to 18 but would add to negative 10 now, right? So just to help myself figure this out, I write out all the different factors of 18. And what I notice here is that actually none will make negative 10. There's no way for me to come up with some combination of this to make this into negative 10, right? So this is the other reason that I do actually like using the grouping technique is sometimes, you know, you can like drive yourself crazy, like, oh, does it factor? Does it not factor? And now I can really clearly and confidently see, right, there is no way that this is going to end up being negative 10. So ultimately, this is prime. And so actually there was nothing that we had to do with this one. So that was a trick question. Like I said, I like to keep you on your toes. Okay, so let's talk about one more. So this one is x squared plus 7xy plus 12y squared. Okay, so the thing that makes people nervous about this one is that we have y's in there. And so then it's like, oh, what do we do? So the trick that I like to use for this is I just like to say, so how would you factor if there were no y's, i.e. how would you factor x squared plus 7x plus 12? Okay, so x squared plus 7x plus 12, that just factors x plus 3, x plus 4, right? Okay, so then what would I do to get the y squareds and the xy's in there? Well, all you really need is you just need to tack a y on to those numbers at the end. So now the way to factor this will just be x plus 3y, x plus 4y. And then look, you get 3xy and 4xy, and that'll get you your 7xy. So really you're just tacking on an extra variable or letter in this case. Okay. So those were kind of a few tricks that you can try as you're working through factoring. The last thing that I want to talk about are some tricky difference of squares type problems. So the whole idea with this is that you really just want to follow the pattern, okay? So let's warm this up for a second. So I've got 3 examples and you can kind of see what I mean by following the pattern. So if I start with x squared minus 16, so how does that factor? That factors x minus 4 times x plus 4. Cool. Okay, what about x squared minus 25? Well, that one's going to factor x minus 5, x plus 5. So this idea here is that we're writing the same number. One is positive, one is negative, right? Okay, so this pattern can actually be applied to all kinds of different things as long as they're perfect squares. So for instance, x squared minus 16 over 25. Now, at first, your brain might be going a little crazy because it might be like, it's a fraction, what do I do? But my friends, we 100% like did this, right? So we know how to do this for 16. We know how to do this for 25. So we 100% know how to do this for 16 over 25. So this is going to be, just think about the top, think about the bottom. For the top, what makes this a perfect square is that it's 4 and 4. For the bottom, use 5 and 5. So how is it going to factor? X minus 4 over 5, x plus 4 over 5. So again, consider writing all that down, pause the video if you need to, and just think about that for a second and make it make sense before we move on. Okay, so let's keep going. So now, instead of having x squared minus 16, what if I have 16 minus x squared? Okay, so in this case, the number comes first. So the easiest way to factor this is to just reflect that in your factoring then. So now, because we need this x squared to be negative, so the best way to make that happen then is 4 minus x, 4 plus x. And this negative x times x will give you a negative x squared. Now, I do want to throw out that I've noticed that some books will bring up another way to do this. And so I'll just show you. I actually don't like this because it's like something that you have to remember, but it's a little bit of an extension of something we've already talked about. So some books will talk about factoring out -1 first. So if I factor out -1 first, now the negative x squared becomes positive, and then the 16 becomes negative. So I can basically flip the order and then factor this. So then I'm back to -1 times x minus 4, x plus 4. So these are two different ways to get to the same answer. My question is, which is easier? This is 100% preference, so it doesn't matter which way you want to do it. It's just whichever way makes more sense to you. So that's actually an open question, which is easier. Okay, so let's keep going. So next, I've got 25x squared minus 16y squared. Okay, so I think you can do this. Pause here, give it a try, hit play when you're ready. Okay, so we've been using the same numbers over and over. This is going to be 5x minus 4y and 5x plus 4y, right? So we're just recycling that, but we're now kind of tweaking it for these different variables and different placements of the numbers. Okay, and the last one. Okay, and so for this last one, so 16 over 25x squared minus 4 over 9y squared. I want you to take a second to think about this. Think about how these are perfect squares. Take the square root of the top and bottom of everything, and then, hit play when you think you've got an answer. Write something down and then hit play. Okay, so this is going to factor 4 over 5x minus 2 over 3y, and then 4 over 5x plus 2 over 3y. So I think this is actually pretty cool. This looks really hard, but it's really just a pattern, right? And so once you kind of understand that pattern, you just kind of apply it over and over. So when you see something that's a super difficult difference of squares, what I would encourage you to do is just to remind yourself of what that pattern is. And once you kind of establish that pattern, then you can go to one of these crazy ones and then apply it there. Okay, cool. So that brings us to the end of this video. If you found that helpful, please consider hitting the like button or subscribing to the channel. And so I will talk to you guys in another video. And just a reminder, I do have extra examples of kind of all of these topics if you feel like you need to see a few more from this review. Thanks for watching.